Hi, in this video we will talk a bit about LRU Cache, how it works, and how you can create one. So here's an array in memory that will be acting as cache. Max capacity is 3. It will take objects from your program and store them in this array. On the right, there's a program that has 3 objects that it wants to store: a string object, an integer object, and a composite object. Let's label the indexes of the array. Now in LRU Cache, we always keep the most recently used item at the front of the array. As you can see, our cache is full. If the program tries to add any other object in the cache will have to start evicting items, and the least recently used one will go out first. So in this case, our program was only adding items, so the most recent one is the one that was lastly added. And the least recently used is the string object hello. Let's forget about adding more items to the cache for a sec. Let's only focus on accessing items. Suppose your program wants the integer object 1. After you access it, the cache will reorder itself to make this integer as most recent. What if program accesses string object hello? Again, the same thing, the cache will move this to top of the array because it's the most recent now. So if you notice shifting the string object hello, which was the last item in the cache, aka the least recent item, it took us 3 shifts in this array. Can you guess how much it would take for an array of size n before I explain it? Let's look at what happens when our program wants to add more items to cache. So let's say now your program wants to add this integer item 5 to the cache. But the cache is full, so it will evict the least recently used item to make room for this integer item. An array perfectly tracks the most recent items added to it over a period of time. But there's one problem. If we use array as a cache store, sometimes cache would need to push the last item to the very front to make it most recent. Let's see how. Here's an array of max capacity n acting as cache. Now, if you want to move the least recent item to the end of the array, you would have to do n operations. Can you see that? This will move to the end of the array. That's one operation. And the remaining n-1 items need to be moved 1 up each, so that will be n-1 operations. So total operations will be n, so time complexity for array cache will be O of n. There's a better data structure to help us here, that is a doubly linked list. So in an actual LRU cache implementation, we use a linked list instead of an array to store items, simply because shifting the least recently used item to end is an O of 1 operation. So the first node is least recent as it was added first. And the last node is the most recent one. That's it for this video. If you enjoyed this, make sure to give a thumbs up. Make sure to check the description for LRU Cache source code using linked list. Your feedback will help me make better videos. Also tell me if you like these animated videos or you prefer more manual face-to-face way of explaining concepts. Let me know.